Tarud, and this is my team, Vader and Cheung, and we are presenting to you a concept of the Lego Buddy. Objective: to develop a robot that will interact with children when they play with Lego pieces by collecting the pieces that are laid out and brushing them into the conveyor belt and then sorting them by colors, red, in this case, red, yellow, and white. And then this is done, of course, through light sensors that are placed down here. Evaluated conceptual design. Various concept designs were developed. Basically, we have some restraints and considerations. Basically, we were using the platform for the Lego Mindstorm, and you need to be extra creative because none of this comes like this. They come by little pieces at a time. So you have to actually think out of the box and think what you want to build and make sure that you can create those dimensions to produce a robot. Go back. We implemented some sensors, and that did not include the Lego Buddy. We did the touch sensor, the light sensor, and the infrared sensor. We also we did track, and we switched to wheels because it made it better for our gears to actually work with our brush and the conveyor belt. Conceptual designs.
Initially, for the brush, we had solid pieces, and when we were running it, it will actually, since it was solid, it will actually run over it, and as a result, we use cardboard as a brush. And also, we found that right after conveyor belt, there's a gap, and in order to accommodate the gap, we use a piece of cardboard so it would transport onto the sorting cart.
The conceptual design number 2 is pretty much our Lego Buddy. The first one actually included a hand, but the hand was not as precise picking up the Lego pieces. So we went with the brushing onto the conveyor belt. Components and materials.
Okay, for the materials and components, it's basically made out of 2 brains, 2 Lego brains. Also, there are light sensor, one for navigation and one for sorting out the colors. And also for the touch sensors, we have for navigation. And for the remote, we have 3 touch sensors for the remote. For if, let's say, this one is pressed, it will go left, and this one, the one in the front, if you press it, it will go forward, and this one will go to the right, etc., etc. For the kinematic design and for structure, we have the gears. Some of the gears is, as you can see, some of the gears is 1-to-1 ratios, and the other one is 3-to-1. Okay, this is a software we used, and it's very graphical. It's in the video.
Okay, so basically, go back on. What we did for the software development, it's basically what we've learned so far, but instead of writing it out, we have more of a visual look and programming accessibility. It's easier for the user, and then you can actually, not only that, but you can do it on a flowchart kind of way, and then that way you understand it better. It's a little bit different, but the good thing about it is that for those who don't know how to maybe use the exact words, you can loop it and it's more visual, and you can track down if there's any errors or not before you actually run. Designs of experiments.
So what we did was we tried to, since it's so complex and all the pieces were very hard to model, we just did a very basic modeling of the chassis, the 2 side parts here. And what we actually did as far as some sort of simulation was, in case this would hit, let's say, a wall, I mean, it's not going to have that much force, but if it would encounter force, this is what we put here in the front brakes here and the gear here. And for the restraint, since you have to put a restraint in SolidWorks, we just put it back here. Over there on the right hand side, you see a very coarse mesh of the gears that we used. Since it has a lot of holes, the mesh sometimes will fail. So we had to take some of the pieces out for the simulation, and the simulation was giving us trouble. It would always fail, but this was what the SolidWorks modeling that we did.
For the design of experiments, the Lego blocks of different colors were scattered on the floor, and then for the Lego body, it will be placed autonomously. It will navigate itself and to collect the large pieces, and it will transport it through the conveyor belt and sort out the colors. And it also have the remote right here, as we mentioned before, as a secondary function, or if the kid wants to play with it.
So, like I mentioned before, some of the load and the restraints, we put 1/4 of a Newton, which is really, really small. I mean, this thing is not going to be going fast anytime soon. And like I mentioned before, the restraining here is in the back. Don't check the footlights, though.
Basically, we did the testings on the Lego body. We actually had him pick up a couple Lego pieces and sort it. We did encounter some problems that we can work on for adjusting the design. Basically, we came up with a conclusion that working with Lego pieces is completely unstable, especially for the tasks that we wanted to perform, because gears will become loose and you would constantly have to start tightening them up. Even though the design, the structural design and the kinematics is correct, the consistency of the piece of the design being held together was not there, so it could not compensate. Now, we have a video of what is not shown.
It's on my phone.
We have a video that we will show to you of the dynamics of the Lego body and explaining how it actually works. We actually have it picking up a couple pieces so that you can see how it does. We can't demonstrate it right now because one little gear gets, not gear, but the little engine gets stuck. We can show you. Basically, this one here is giving us problem. And once again, this is because the system is not stable because of the structure. It started buckling under all the weight in the center. So let's go ahead and show the video now of the Lego body working. And we also have an explanation of the screenshot of the program. And then where's the software? Yes. Okay, and this is the shots of the video of the software. Here we have the Lego Buddy software, and it'll be explained by Dr. T.
This is a controller. This is a remote control. Each of these touch sensors will instruct the Lego body to move forward, turn left, or turn right. Here is the
actual
code.
screen that you see.
Whenever the IR sensor senses it to be. Alright, as for the first part, right here, right here. Go on with the first part. Right there. This tells the Lego body to go forward no matter what, unless the remote control tells it to do something else. And on the first column here, first, second, and third columns, they are basically telling the brain if it receives an infrared message from the remote control, it will go forward, rotate left, or rotate right on the last one. and then right. These two columns, this is the sorting mechanism for, depending on the color, it will rotate the motor in the back to left, right, or leave it as it is. And for the last two sensors, that's for the navigation part, which is the touch sensor. If the touch sensor is being pressed or if it hits something, it will make a right, and as well as for the light sensor. Right or this?
That's fine. Any questions?